Hello everyone, welcome to Top Scholars, the smart learning app. Today in this lecture, we are going to discuss some of the previously asked questions from the last 5 years from the chapter Electricity from 10th standard CBSE board. So if you are preparing for the 10th standard examination, the board examination of CBSE 10th class, then this video lecture is going to be very important for you, because we are going to talk about the last 5 years of questions from this chapter itself. So first of all, what we are going to do is, first of all, we are going to have a look at how many questions were asked in each year for different marks. For example, you can see here in the year 2019, we have one question for 1 mark, isn't it? And then we have got one question for 2 marks. Then we have got one question for 5 marks. That means a large question. Similarly, in the year 2020, we have got one question for 1 mark and 2 questions were there for 3 marks. Similarly, here in the year 2021, we have got one question for 1 mark. Then we have got one question for 3 mark and one question for 5 marks. So total, we can see here there are 8 marks, isn't it? Or in fact 9 marks in this year for this chapter. And here if you look at this, in this year 2022, we have got 2 questions asked for 3 marks. That means total 6 mark questions in this year. Then we have got 3 questions for 1 mark in the year 2023, and there is one more question for 5 marks. So total, we can see 3 plus 5, that is 8 marks questions were asked in this year 2023. And in fact, we can see here the total number of questions, isn't it? So there are total 6 questions of 1 mark, 1 question of 2 mark, and 5 questions of 3 mark, and then 3 questions of 5 mark. So in this way, we can see here in total we have got multiple questions. 6 plus 1, 7, and 7 plus this 5, 12, and 12 plus 3. That means we have got total 15 questions that were asked in the last 5 years. So that has been the trend, okay, for the last 5 years. So we can see here this chapter is quite important from the exam point of view for you all, okay, if you are preparing for science subject. Okay, now moving on, this same statistics has been displayed over here in the form of a graph. Okay, so you can see here different years have been indicated over here, and different kinds of questions, that means 1 mark, 2 mark, and 3 mark questions, okay, have been represented over here with different colors. Okay, so this is the same statistics. Okay, you can have a look at this graph also, that will also give you some idea. So in the year 2023, you can see large number of questions were asked as compared to other years. Okay, so this shows that this chapter is quite important for you for the board examination. Now what we will do is, we are going to now move into the actual questions. We are going to have a look at all the questions that were asked in the last 5 years, and what we will do is, out of those all questions, we will try to solve some of the questions, as well as we are going to discuss all the questions. Okay, so let's get into this lecture and let's see what are the different questions. So here, first starting with the year 2019. So in the year 2019, this is the first question. What is the function of galvanometer in a circuit? And it's a 1 mark question. That means it's just a small question. That means you have to write a answer in a very short manner. Okay, so here, what is the function of galvanometer? So as we know, galvanometers are used to measure current, okay, in any electrical circuit. So that should be the answer. Then we have got the second question. While studying the dependence of potential difference across a resistor on the current passing through it, in order to determine the resistance of the resistor, a student took 5 readings of different values of current and plotted a graph between V and I, okay, between V and I. He got a straight line graph passing through the origin. What does the straight line signify? Write the method of determining resistance of the resistor using this graph. So this is a 2-mark question. So again you have to write a short answer for this. So it's a quite short answer question. So what we'll do is we'll discuss this question later on. Okay, this is there at the end of the lecture. So right now let's not discuss it. We'll discuss it later on. Next question from this year is, what would you suggest to a student if while performing an experiment he finds that the pointer or needle of a ammeter and voltmeter do not coincide with the 0 marks on the scales when circuit is open? No extra ammeter or voltmeter is available in the laboratory. So over here there is a student who is performing an experiment, but here the ammeter and the voltmeter that he has used has got certain error, and you can see here that the pointer or the needle does not coincide with the 0 marks, isn't it? So as we know, in case of a voltmeter or in ammeter, we have got markings like these. There is a 0, there is 1, for example, there is 2, okay, there is 3, there is 4, something like this, and there is a needle, and when there is no current, or let's say there is no voltage, then these devices must point at 0 or on 0, right? But in this case it is not pointing at 0. It may be just a little bit ahead of 0 or just a little bit back of the 0, right? Behind 0. So now in this case we have to find out what exactly is happening and what would you suggest such a student, okay, if there is no extra ammeter or voltmeter is available in this case. So over here the first thing that you can suggest to the student is that you have to find out what kind of a 0 error is it, whether the 0 error is positive or negative, okay. So in this case you have to suggest the student that first find out what kind of a error this is. So basically over here the pointer is not pointing on 0, that means it is a 0 error. Now what we have to do is we have to identify, or that student has to identify whether it is a positive 0 error or it is a negative 0 error. And if it is, let's say, a positive 0 error, then he has to find out the value of that particular 0 error. Let's say the needle points here instead of this 0, then he has to find out how much value is it, okay. Or if this needle points somewhere here, then the student should find what value, or this angle represents how much value of current that he has to find out. So this is what he should do and this is what we should suggest. And if once this value is found out, okay, then we can either add or subtract this 0 error, okay, in the actual reading, okay, depending on whether the error is positive or negative. So this is what he can do. Moving on to the next question. With the help of a suitable circuit diagram, prove that the reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. And it's a large question, as you can see, it's for 5 marks, okay. So here we have got another question, okay, with the first question. You can see here in this question we have got 2 parts, A and B. So B part says that in an electric circuit, 2 resistors of 12 ohm are joined in parallel to 6 volt battery. Find the current drawn from the battery, okay. First of all, let's have a look at this question. So over here we have to derive, or first of all we have to prove that the reciprocal of the equivalent resistance of the group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistance. That means over here they have asked us this question: 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Is it? And basically this is an equation for finding out the equivalent resistance, okay, of the combination of parallel resistance, right? Parallel resistors. So suppose we have got 3 resistors, okay, 1, 2 and another one, and as you can see all these resistors are connected in parallel, let's say with a standard battery, okay, with a positive terminal here and a negative terminal here. Here is, let's say, R1, here is, let's say, R2, and here is, let's say, R3. Okay, so these are the 3 resistors which are connected in parallel. So over here what we can do is we can use the Ohm's law and we can derive this equation. So this is an easy derivation, okay, we can easily prove this, okay. There is a very simple derivation, very simple method for this. Moving on to this next question: an electric circuit, 2 resistors 12 ohm, okay, are joined in parallel to 6 volt battery. So that means here instead of 3 resistors we have got only 2 resistors, okay, and they are parallel, okay, and both are 12 ohm. So you have to find the current drawn from the battery. That means how much is the total current. If there are 2 resistors, then this total current is divided into these 2 resistors. So what would be that value of I that we have to find out? So over here what we can do is we can use this formula itself. First we can find out 1 upon R equivalent, then we can find out R equivalent, and once we get R equivalent we can find out I by using the formula V upon R, okay. So we can easily find out this answer. Moving on to the next question. So here again from the year 2019, question number 3, an electric lamp of resistance 20 ohm and a conductor of resistance 4 ohm are connected to 6 volt battery as shown in the circuit. So we have got a 6 volt battery, then we have got a 4 ohm conductor, okay, and then we have got a bulb having resistance 20 ohm. So over here what we have to calculate is the total resistance of the circuit, okay, which can be easily calculated, isn't it? So over here we have got 20 ohm and this is 4 ohm. So this is a series connection of resistors. So total will be 24 ohm. Then we have got the current through the circuit. So once we get this value, that is total resistance, or we can say the equivalent resistance, then we can use the formula, that is V is equal to IR, nothing but the Ohm's law, okay, and we can find out what is the current. So current will be equal to V upon R equivalent, right? So here this equivalent value is 24 and V is also given, that is 6. So 6 upon 24, isn't it? So that means it will be 1 upon 4. Okay. So this is going to be the current in this circuit. Okay. Next is the potential difference across the electric lamp and second the conductor. So here we have to find out what is the voltage or potential difference across this bulb. Here let's call this V2 and here the potential difference, let's call it V1. So again we can use the Ohm's law, okay, and we can easily find out V1 is equal to IR1, and similarly we can find out V2 is equal to IR2. Over here, R1 is the resistance of this particular conductor and R2 is the resistance of this particular electric lamp. Okay, and I is common here because it's a series combination of resistors. So definitely I is going to be same. So just putting the numbers, we can easily calculate what is the potential difference across both of these resistors. Last is we have to find out the power of this particular lamp, and we know the formula, power is equal to V into I, voltage into current. So we know the voltage, we know the current, we can easily find out what is the power, right? So we have just found out what is the voltage as well as current. So just multiply the two and you will get the power. So this is a quite easy question, but it is for 5 marks. So it is a very important question. Okay, it's a large answer question. Moving on to the next question now. Now we are moving to the next, that is 2020. Okay. First question here is, at the time of short circuit, the electric current in the circuit, we have got here 4 options. It's a MCQ, right? Multiple choice question. So vary continuously, does not change, reduces substantially, and here last option is increases heavily. So at the time of short circuit, so whenever there is a short circuit, okay, at your house, for example, what happens? Okay, definitely the current in the circuit increases very heavily, right? So that's why the correct answer over here is going to be option D. Moving on to the next question. 2 bulbs of 100 watt and 40 watt are connected in series. Okay, the current through the 100 watt bulb is 1 ampere. Then the current through the 40 watt bulb will be what? Okay, so again here the options are given 0.4, 0.6, okay, 0.8, and we have got 1 ampere. So again here we can use the formulas like power is equal to V into I, and other formulas are also there. V is equal to IR. Okay, so different formulas we can use and we can easily solve this question also. Okay, so the value of power is given to us, and from these values we can calculate, and it's quite an easy question. Okay, moving on to the next one. In fact, we can see here that this is a series connection, right? So that means both of these bulbs are connected one after another, right? So if they are connected one after another, that means the current through both of these bulbs must be same. That means if 1 ampere is the current through this bulb, then same should be the current through this bulb. That means the correct answer is 1 ampere. And you can also use these equations also to solve this question if you cannot directly answer this question. Okay, moving on to the next question from the year 2020. Now here a VI graph, that means voltage current graph for a nichrome wire is given below. What do you infer from this graph? Draw a labeled circuit diagram to obtain such a graph. Okay, so here we can see for a nichrome wire, okay, we have been given a graph of potential difference and current. Okay, so we have to draw a labeled circuit diagram to obtain such a graph. So it's very simple, right? So here there has to be certain battery or a power supply, okay, and there has to be a nichrome wire having certain resistance. Okay, so let's say this is the nichrome wire here, and what we have to do is we have to note down the current. So there has to be a ammeter, let's say, connected over here, and there has to be a voltmeter to measure the potential difference. So basically this has to be the arrangement to obtain such kind of a graph. Okay, so this is for 3 marks. Okay, Moving on to the next question from the year 2020 again. Write the mathematical expression for Joule's law of heating. Okay. Compute the heat generated while transferring 96,000 coulomb of charge in 2 hours through a potential difference of 40 volt. Okay. So it is a 3-mark question. Okay. So now we have to first write down this Joule's law of heating. Okay. So as we know, heating is equal to, or the amount of heat generated whenever some current flows through a resistor. Okay. Then that equation is I square R T. Or there is another equation, H is equal to V I T. So using this, we can actually find out what is the amount of heat generated. Okay. Over here, that has been asked, while transferring 96,000 coulomb of charge in 2 hours. So that means this information, okay, that can be used to find out the current, because current is equal to amount of charge divided by the time required to flow. So over here we can put this number, and 2 hours can be first of all converted into seconds. Then it will be current. Okay, so we can put this number over here, and then we can easily calculate this heat that is generated. Moving on to the next question. Now from the year 2021, the first question is, name the instrument used to detect the presence of current in a circuit. So we know this answer very easily, right? So over here, we know that for measuring current, we use galvanometer. Okay, galvanometer. Next question is, 2 lamps, one rated 100 watt at 220 volt and other 60 watt at 220 volt are connected in parallel to the electric mains supply of 220 volt. Draw a circuit diagram to show this arrangement and calculate the current drawn by the 2 lamps from the mains. So this question will be discussed later on. Okay, at the end of the lecture, we are going to also discuss this in detail. So right now, we'll not discuss it. We'll move to the next question. Here is the next question. Okay, so over here in the year 2021, the next question is, here you can see there are few parts of this question. Although electric kettle and electric toaster were used simultaneously in the kitchen to prepare breakfast for the family, yet the two devices could work efficiently due to fuse used in the electric circuit. Now, so this is some information that is given, and here are some questions that have been asked. So first question is, what is a fuse? Write the material used in fuse wires and how is a fuse connected in an electric circuit. Then next question is, state the ratings of fuse used in an electric circuit. Then the next question is, what is the function of a fuse? How does it perform its function? Next is, a device uses 1 kilowatt electric power when operated at 220 volt. Calculate the rating of the fuse to be used. So over here, this question is related to the electric fuse that we generally use at our household, right? Because we know fuse is very important for protecting our electrical appliances from any kind of a surge of current. Okay, because whenever there is a surge of current, then there is a chance that our electrical appliances that will be damaged. So just to prevent this, we use electrical fuse, or there is a very thin wire that we use, which is called as fuse. Okay, so this fuse basically is used to protect okay, our devices, especially the electrical appliances, from any kind of a damage due to heavy current, because sometimes there is a fluctuations in current that happen due to multiple reasons, and to protect our devices, this arrangement or this fuse is very much required. Okay, so we can easily answer this question also. Moving on to the next one. Draw a labeled circuit diagram of the circuit used to show the variation of potential difference across the ends of a resistor with current flowing through it. If you use this circuit, what relation would you find between the voltmeter reading V and the ammeter reading I? So over here, we have to draw a labeled circuit diagram of the circuit used to show the variation of potential difference across the ends of a resistor with current flowing through it. So there is a resistor and there has to be a source, that means there has to be a battery, okay, and to measure the current there has to be a ammeter, and here across this resistor we must have a voltmeter, okay, positive and negative, okay, and here also positive and negative. So this is a resistor across which we are measuring the voltage, and there is some current flowing through this resistor. So this is basically the diagram, and if you use this circuit, okay, what relation would you find between the voltmeter reading V and the ammeter reading I? So as we know, according to the Ohm's law, V is equal to I R, isn't it? That means basically, since R is constant, so V is proportional to I. That means the potential drop or potential difference across the resistor depends on the current that is flowing through it. So this would be the relation, and that's why we are going to get a straight line graph. If we draw a V versus I graph, then we get a straight line, something like this. So this is the kind of a relation that we are going to get. Next question is, a wire of given material having length L and area of cross section A has a resistance of 4 ohm. Find the resistance of another wire of the same material having length L by 2 and area of cross section 2A. So here we have to use the formula of resistance for a given length of a wire, which is nothing but rho L upon A, where over here R is the resistance of the given piece of a wire. Let's say this is a piece of a wire, somewhat like this. This is the area of cross section. This is the length of the wire. Okay, and this material has a resistivity rho. Then in such a case, this piece of a wire will have a resistance rho L upon A. So using this formula, this problem can be easily solved. Okay, moving on to the next question. Now we are moving to the year 2022. So here we have the first question A. Three resistors R1, R2 and R3 are connected in parallel and the combination is connected to a battery, ammeter, voltmeter and key. Draw suitable circuit diagram and obtain an expression for the equivalent resistance of the combination of the resistors. So this is very easy question. Okay, here we have to just draw three resistors R1, R2 and R3. Here we can draw R1, R2, then we have got R3. All these are connected in parallel and there is a battery which is connected here, positive and negative, R1, R2 and R3, and there is a ammeter and voltmeter. So here there has to be a ammeter, and here across all these resistors there has to be a voltmeter just to measure the voltage across each of these, because in parallel combination the voltage across each resistor is constant, or we can say same for all of these. Okay, now so this can be easily solved. Then the second question here is calculate the equivalent resistance of the following network. So here is a network that is given: R1 5 ohms, R2 10 ohms, R3 10 ohms, and R4 is again 5 ohms. So first of all, what we can do is to find the equivalent resistance between A and B. First we can solve this. Okay, R2 and R3 are connected in parallel. So in parallel, okay, there is a formula, as we know, 1 upon R equivalent, okay, is equal to 1 upon R1 plus 1 upon R2. See, here we have got R2, so that's why we'll write R2, plus here we have got R3, so we'll write R3. So if you add these numbers, finally we are going to get 5 ohms, and then this combination has an equivalent of 5 ohm. Then this is connected in series with R1 and R4. All these three are 5 ohms, and in series we know what happens, all of the resistances just add up. So therefore the total resistance or the equivalent resistance in this case would be 15 ohm. So this would be the answer, and it's a 3-mark question. Moving on to the next question from the year 2022 again. First, here part A, define electric power and its SI unit. Then second, two bulbs rated 100 watt at 220 volt and 60 watt at 220 volt are connected in parallel to an electric mains of 220 volt. Find the current drawn by the bulbs from the mains. Or there is another question for this. B, state Joule's law of heating. Express it mathematically when an appliance of resistance R is connected to a source of voltage V and the current I flows through the appliance for a time t. Then in the same question we have got another one. A 5 ohm resistor is connected across a battery of 6 volts. Calculate the energy that dissipates heat in 10 seconds. Okay, so this is a question. Here we have got two questions. This is an optional question. So out of these two, you can solve any one, but we are going to have a look at all these. Okay, this question is a repeated question. Previously also we had same kind of a question in the previous year. So this question will be discussed at the end of the lecture. Okay, so right now let's not discuss this. Then here we have got another one, Joule's law of heating. So we know what is Joule's law of heating basically. Basically, whenever some current flows through a wire, some conducting wire, then the wire gets heated up. Some heat is generated. Okay, so that is called as the Joule's law of heating, and there is an equation also for finding out the heat, that is I square RT, where I is the current, R is the resistance of the particular conductor, and T is the time for which the current is flowing. And this question can also be solved easily by using the Ohm's law and other equations. Okay, moving on to the next question now. Now we are moving to the year 2023. If 4 identical resistors of resistance 8 ohm are first connected in series so as to give an effective resistance Rs, and then connected in parallel so as to give an effective resistance Rp, then the ratio Rs upon Rp is what? So that means over here we have got 4 identical resistors, each having a value of 8 ohm. Okay, so first of all we have connected them in series. right? So if we are connecting them in series, what would happen? Definitely they will add up. So 8 fours are, it is going to be 32. So that means RS is going to be 32 ohm. Whereas once we connect them all in parallel, then the formula is different. Then 1 upon R equivalent, here we have written it as Rp. So it is going to be 1 upon 8 plus 1 upon 8, 1 upon 8 plus 1 upon 8. And if you add all these, what we are going to get is 4 upon 8, 1 upon Rp. So therefore, Rp is equal to 2 ohms. So we have found out Rs is 32 and this is 2. So over here we have to find out the ratio. So Rs is 32 and this is Rp is 2. So 32 divided by 2 is nothing but 16. So the answer is 16. Moving on to the next question. In domestic electric circuits, the wiring with 15 ampere current rating, okay, is for the electric devices which have higher power ratings such as geyser, lower power ratings such as fan, then metallic bodies and low power ratings, and non-metallic bodies and low power rating. So definitely when we use 15 ampere rating, generally this is used for higher power ratings such as geyser. Okay, so the correct answer in this case should be option A. Okay, moving on to the next question. In the following diagram, the position of the needle is shown on the scale of a voltmeter. The least count of the voltmeter and the reading shown by it respectively are what? So over here, first we have to find out the least count and then what is the reading that is being shown. So here we can see this. For 10 lines we have got 1.5. Okay, so 10 divisions of this scale, okay, represents how much? 1.5 volt. Okay, so this is for 10 divisions. So least count means what? The smallest measurement that can be made on this particular scale. So smallest measurement is this one, isn't it? So this division corresponds to what? That is what we have to find out. So definitely what we have to do is we have to divide 1.5 by 10. So it is going to be 0.15. Okay, so 0.15 is the least count and we have been asked to find out what is this reading. So it's very simple. This is 1.5, then this is 0.15, 0.15 twice. If you do, it is going to be 0.30. So 1.5 and 0.3, if you add, what we are going to get is 1.8. So that means the correct answer should be here, that is option C. 0.15 volt is the least count and 1.8 volt is the reading shown by this scale. Moving on to the next question now. Again from 2023. An electric iron consumes energy at a rate of 880 watt when heating is at maximum rate and 330 watt when the heating is at minimum. If the source voltage is 220 volt, calculate the current and the resistance in each case. Okay, so over here we have to calculate the current and resistance in both of the cases, when the heating is at maximum and when the heating is at minimum. Also there are some more questions. What is the heating effect of electric current? Then find the expression for the amount of heat produced when the current passes through resistor for some time. So basically we are going to discuss this question at the end, okay, afterwards, after all these questions are over. Okay, so let's not discuss it right now. Moving on to the next question. Okay, so now we are starting with actual description of all the questions. So here we are going to discuss each and every question, I mean few questions from the last 5 years, okay, and we are going to discuss them in details. So first question is, what is the function of a galvanometer in a circuit? So the solution for this is very simple. As we have just discussed previously also, galvanometers are basically used to measure the electric current flowing in a electrical circuit. So as we have discussed earlier also, galvanometers are basically used to measure electrical current in a electrical circuit. Okay, so basically this is a picture of a galvanometer which has a zero marking at the middle. Okay, and here you can see some markings. Depending on the direction of the current, the needle will deflect in a particular direction. So if the current is positive or maybe negative or in any direction, this galvanometer is capable of showing current or indicating current, okay, flowing in any direction. So this is galvanometer. Moving to the next question. So two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to the electric mains supply of 220 volt. Draw a circuit diagram to show this arrangement and calculate the current drawn by the two lamps from the mains. So first of all, we have to draw the circuit diagram. So first of all, let's look at what is given here. So voltage is given 220 volt, power of the first bulb is 100 watt, power of the second bulb is 60 watt, that's why it is P1 and P2. In parallel combination, the current gets divided among the resistors. So therefore the net current is the sum of the current through individual resistors. So I is equal to I1 plus I2. So here we have drawn this. This is the power supply, that is 220 volt. Here we have the 100 watt bulb and here we have got 60 watt bulb. Then this is the total current that is drawn by the circuit, and here this current gets divided into two directions and we have named these currents as I1 and I2. So here we know this formula, power is equal to V into I. So therefore I is equal to P upon V. So we will use this formula to solve this problem. Okay. So here for lamp 1, I1 would be equal to P1 upon V, because V is common for both, but power is different for both lamps. So this is 100 upon 220 and the current would be 5 upon 11. And then for the lamp 2, I2 is equal to P2 upon V, which is equal to 60 upon 220 and it is equal to 3 upon 11, okay, ampere. So this is the current passing through each of the bulb. And now we want the total current. So let's just add this, and after adding, what we get is 0.73 ampere. So this would be the answer for this particular question. Moving on to the next question. An electric iron consumes energy at a rate of 880 watt when heating is at the maximum and 330 watt when the heating is at minimum. We know whenever we use electric iron, there are options, right? We can rotate the knob and we can set the heating to maximum or to the minimum or maybe somewhere in between. So when the heating is at maximum, then the power rating is 880 watt, and when it is at minimum, then it is 330 watt. If the source voltage is 220 volt, calculate the current and the resistance in each case. So we have to calculate what is the current in this case and what is the resistance of that particular electric iron, okay, in both of these cases. So here there is another question, what is heating effect of electric current? And then third question is, find the expression for the amount of heat produced when a current passes through a resistor for some time. Okay, so this is a large question asked for 5 marks. So let us discuss this. So first of all, when heating is at maximum rate, in that case power is 880 watt, then voltage is 220 watt, then we know that power is equal to V into I, and then using this formula we can calculate I. So I would be here 4 amperes, isn't it? Now, so we have got the value of I when the heating is at maximum. Now we have to also find out resistance. So resistance is equal to V upon I, and V is 220 volt and I is 4. So dividing this, we get 55 ohm. So therefore, we can say that when the heating is maximum, then the resistance of this electric iron material is 55 ohm. Now moving on, when the heating is at minimum rate, in that case again we can use the same formula, but here the power is 330 watt, voltage is 220 volt. Okay, we know that power is equal to V into I, and arranging this equation, what we get is I equal to 1.5 amperes. So we have got I. From this we can calculate R. So R is equal to V upon I. V is 220, I is 1.5, and after dividing we get R equal to 146.6 ohm. So this would be the answer. Now here there is another question. What is an heating effect? So when an electric current passes through a conductor, the conductor becomes hot after some time and produces heat. This effect is called as heating effect of electric current. Okay, then we have got the last question here. Find an expression for the amount of heat produced when a current passes through a resistor for some time. So consider a current I flowing through a resistor of resistance R. Let the potential difference across it be V. Let T be the time during which a charge Q flows across the resistor. Now, the work done in moving the charge Q from one point to another through a potential difference V is V into Q, because we know the formula for potential difference is work done per unit charge. So therefore, arranging this equation, work done is equal to V into Q. This is a standard equation that we know. So therefore, in moving the charge Q from one point to another through a potential difference V, we require how much work? V into Q. Therefore, the source must supply energy which is equal to V into Q in time t. Hence, we can write here power. What is power? Power is work done per unit time, and work is V into Q. So therefore, this is our equation. Let's call this equation number 1. Moving on. So here from this equation we can write I is equal to Q upon T, right? This is the standard equation of current. Current is rate of flow of charge, that means charge per unit time. So here power is equal to V into I. Okay. So energy supplied in time T is equal to power into time, because power is equal to energy supplied per unit time or work done per unit time. So energy supplied or work done is equal to power into time. This is our standard equation. Okay. So therefore, P into T is equal to VI T, because P is equal to VI. So we have just put the value of P over here. Now from equation 3 and 4, okay, what we can do is the energy supplied gets utilized in the form of heat, right? So H is equal to V into I into T, and Ohm's law says that V is equal to IR, right? So what we can do here is we are going to substitute V in H equal to VIT. So instead of V, what we will write is IR according to Ohm's law, and after we solve this, what we get is H is equal to I squared RT, and this is the equation for finding out the amount of heat produced when a current I passes through a resistor, okay, for some time T. And this is our final equation, and this question is for 5 marks. So in this way, today in this lecture we have discussed multiple questions from the chapter electricity, okay, and those questions which were asked in the last 5 years. So we have discussed some of the questions, as well as at the back we have solved some of the questions. Okay, so this is a very important lecture for all of you if you are studying in 10th standard in CBSE board. So I hope everything that we have seen or studied in this lecture is very much clear to all of you. Thank you so much for watching this, and all the best for your exams.